So it's really nice to be here in Leeds. I'm a northerner, I'm from Newcastle, although I went down south so long ago that my accent is kind of coming to meet me. I'm sort of expecting to be around Essex at some point. But it's really nice to be here. So I'm going to talk a bit about grid layout, of course, because that's what I go around the world talking about. And I think it's really great, we're a year into having grid in browsers. I was talking about grid layout for about 5 years before it ended up in browsers, which was starting to feel a little bit like I was talking about some kind of CSS vaporware. So I was pretty relieved when it did actually get out there and get into browsers. And, we've got really good browser support at this point in modern browsers, and a lot of people have started to ship sites using it. And there's lots and lots of production websites out there quite heavily using grid layout at this point, which is really exciting as someone who was involved with the spec for quite a long time. We've actually got a first draft of Grid Level 2. I was at the CSS Working Group meeting a week or so ago in Berlin, and we talked about Grid Level 2 and the subgrid feature, which is going to be part of that. And I get an awful lot of questions. As mentioned, I'm very happy to answer any questions as I'm hanging around about grid or anything else CSS. I get a huge amount of questions. I get them sent to me, and I really, at this point, can't answer all of the email I get on grid questions and so on. And what I try and do is take those questions and turn them into articles and so on that are going to help lots of other people. And also from those questions that I get, I realise there are a few things that are kind of fundamental things about CSS that are confusing people, and that are confusing people about grid. And the first of those is sizing. People are pretty confused about how big things are, and very confused about how grid and flexbox distribute space. And I think the reason this is confusing is that a lot of us have spent, we've spent years and years using layout methods that are actually very straightforward in terms of how big the items in the layout are. We're sizing these with length units, so pixels or ems, or with percentages, which actually just resolve to a length. We all know that if we end up with more than 100%, bad things are going to happen in our layout if we're using floats. And so we have things like fluid grids, these sort of responsive design methods of sizing things in percentages. And the percentages you end up with when you do that kind of calculation don't look very pretty in your CSS, but it's understandable. It's relatively simple to understand. And with things like box sizing border box, that made everything an awful lot easier for us, those of us who'd been doing CSS for a long time and trying to work out the size of things with margins and padding. And I think there's an awful lot of people today who have learned their CSS via a layout framework. There's a lot of people who are working in front end today who've never really written a layout themselves. They're using a framework, which is no bad thing because layout was really nasty to deal with before we had things like Flexbox and Grid. And so using these frameworks kind of helped with that. And then we got Flexbox and Grid. And they seem to behave a little bit strangely as far as sizing goes. Things in our design sometimes get a bit bigger than we expected or are smaller, and we don't really understand where that space is coming from. And what has happened, and what I'm seeing happen, is that people started to create Flexbox-based grids using percentages. And even with grid, I think the first thing that people try and do is create like a 12-column grid, and then things start to end up a strange size. And so they go back to using percentages rather than the new sizing methods because percentages work and we understand them. So because of this, I've kind of declared this year as the year of how big is that box, because I think sizing is absolutely fundamental to understanding and using properly these new layout methods. And so we need to figure out how big a grid is and how big the component parts of that grid are. And we learn some useful things by doing that. And to learn about this, we need to scroll down through the specification. This is the grid specification. And if you keep scrolling down to the bottom of specifications, you're going to find the things that web developers tend to think aren't really for them, that are for browser engineers. And it's down there is where you find the grid sizing algorithm. And that is where you enter the rabbit hole of understanding sizing, because that's the bit that tells browsers exactly how big that box is. And so it's kind of useful to know that yourself, to understand what's going into that. Now, what I'm not going to do is line by line explain the grid sizing algorithm to you. There's only a few of us who are really interested in that sort of thing. But I'm going to highlight exactly the parts of that that really are key to understanding sizing. Because the spec says that each track has specified minimum and maximum sizing functions, and they might be the same. So what do we mean by a sizing function? Well, there's three types of sizing we need to care about. There's fixed sizing, intrinsic sizing, or flexible. Now, fixed sizing is the thing that we're all familiar with. It's how we've been doing layouts for years. So you have length units, pixels, ems, whatever, and percentages are also grouped in with that because although we might see them as being flexible, they actually resolve to a fixed size. And then we have intrinsic sizing. Now, the intrinsic sizing that you're probably familiar with is auto. It's a type of intrinsic sizing. But we also have this specific intrinsic sizing keywords of min content, max content, and fit content. So auto. When you use auto for track sizing in grid, that can generally be thought of as big enough to fit your content. If you use auto for a row, for example, you put some content in there, you put more content in there, the row just gets bigger to take as much content as goes in. It's slightly more complex than that, but roughly, you know, you can sort of, if you have something sized auto, it's going to be big enough to fit your content. With grid, just a useful thing to know about auto is it's the only sizing method that will stretch by default. So if you use auto as a track sizing and there's space in the grid container, it will stretch to take that up. So in this example, I've used auto for the final column track, and what it's doing in the inline direction, it's stretching to take up the rest of the space in the grid container. But the actual size of that track is what you get if you add justify content start. That's the size that the content needs. And that's kind of what we mean by intrinsic sizing is, you know, what size would that thing be naturally? So if you remember that the default for justify content is stretch, auto tracks will stretch. Don't want that behavior, set justify content to start on the container or target the individual item, and then it won't do that. But then we have these new sizing keywords. Now, they're not only for grid. You can use these, or you will be able to when there's browser support, just on a string of text or what have you. At the moment, the new sizing keywords are fully implemented by all the browsers that support grid, so you can actually use these for track sizing. But the other thing about these intrinsic sizing keywords is they expose some of the things about sizing that are important to understand. So we have min content. You can use min content instead of a width for a track sizing, and that will make the track as small as it can possibly be without the content breaking out of the track. So if you've got a track that contains text, you've got a cell that contains text, that's going to take all of the soft wrapping opportunities available. So here I've got 3 column tracks, all sized using min content. So the track content is now going to impact the track sizing, rather than us deciding how big the track is and kind of squashing the content into it. So if we've got any item in that track that's got a width of some sort, or it contains something of a fixed width, well, that's the size. And you can see that the track there that's got a bunch of words in, it's the longest word basically is dictating the size of that track. So that's min content. And then we've got max content, which is the opposite. If something is sized with max content, it's going to try and get as big as it possibly can get. So if you've got a string of text, it's going to unravel. It's not going to do any kind of breaking, which may mean that you get overflows, of course, if it becomes too long. So there's our tracks with max content. And the browser, again, it's going to look at the content to work out the track sizing. And so you can see how those first and second tracks are stretching out to the maximum size of content in that track. And the column track's got an image in there, well, that's going to constrain the size. And we've got an item that's got a width on it, and the item will go to its size of the width, but the actual track size is bigger because it's got some longer text above, which is stretched out to max content. It's worth playing around with these things. All of these slides, and I'll be sharing those, all the slides have got links to a code pen, so you can go and play around with those sizing functions and see how they work. Because then we've also got fit content. And fit content is really useful because it acts like max content until it gets to a value that you pass in, and then it stops and starts doing its wrapping. So I've got 3 tracks here. So the first 2 are clamped at 10M, and the last one at 15ch, which is roughly 15 characters. And so this is what we get. So the first track actually gets to that 10M, and so it stops and it starts to wrap. The second track doesn't, so it's just displaying at max content. And so that's how the fit content works. And that's a very useful thing to be able to say, well, get as big as you can do, but don't get bigger than this, because that's going to cause problems in the design. But yes, remember these concepts. We'll be coming back to this idea of min and max content in a bit. But before that, let's look at this FR unit. Now, the FR unit was designed for grid layout. It doesn't make any sense in any other layout context because it deals with distributing available space in the grid container. And it's a flex unit. It defines a flexible length. So that's a portion of the space. So if I define 3 tracks, I've got 2 of 1FR and 1 of 2FR. So the available space is divided into 4 and shared out. 2 parts is going to track 1 in this case, and 1 part each to the other 2 tracks, which looks like this. And when everyone sees these demos, what they think is, oh, right, so the FR unit shares out all of the space evenly. So if you have 12 tracks of 1FR, that should be 12 equal tracks. But it's not quite that. And we'll see why as we look a little bit further into how sizing works. So now we've sort of looked at the different ways you can size tracks. Now let's figure out the minimum and maximum sizing functions for each track. And we've got this function that we can use when we're sizing tracks, which actually exposes the minimum and maximum sizing function. So min-max, part of the grid layout spec again, it gives us this easy way to start thinking about minimum and maximum sizing. Because if you use min-max for your track, you actually specify the minimum and maximum sizing. So the minimum size is the first value of min-max, and the maximum size is the second one. So here, our minimum sizing is 100 pixels or 10M for those 2 tracks. Now if you use FR units or fit content, then the minimum size of that track is auto. Now remember that auto kind of means big enough to fit the content. And obviously if you have a length or a percentage, you've absolutely said, I want this to be this size, and so that becomes the minimum size. So if we look at our maximum size then, if we've used min-max, we've specified the max. So here I've got 400 pixels or 20M as those track maximums. That'll be the biggest that track can get to be. If you use auto or fit content, then that will be treated as max content unless you've passed a value to fit content, in which case that becomes the max. You've said, you know, only gets big as this value. And if you've used a fixed sizing, well, your maximum is the same as your minimum because you've said, I want this to be 200 pixels or 10M or whatever. So it's never bigger or smaller than either of those. So then we've got the minimum and maximum sizes of our tracks. So we can look at how that sort of plays out when we build our grid. So the simplest case, we've got a fixed size for our tracks. Here I've got minimum and maximum sizing functions exactly the same. So a length or a percentage that can be resolved to a length. Everything's a fixed size, nothing's intrinsically sized, nothing's looking at the content, nothing's flexible. And so here, this is pretty much what we're used to doing with float-based grid systems, really. We're just setting sizing on things. Now in this case, I've still got fixed column tracks, they're still 200 pixels, but we're using auto for the row sizing. And so as we put more content in, the row gets bigger. That's pretty much what we'd want to happen. We don't tend to want to clamp everything to a fixed height. But with grid, we probably want to take advantage of a flex sizing function. So we want to use this FR unit to size the tracks, and then just allow the content to define the row height. And then so as we've got this content, the content is going to have a knock-on effect in really how big that FR is. Because I mentioned earlier that having a set of 1FR tracks doesn't mean that you'll have a set of equal sized tracks. Because if a track is sized with FR units, the minimum sizing function is auto. So it's actually like you've used min-max auto 1FR. So grid gives the tracks an auto minimum and then shares out the remaining space in proportion, not the kind of all of the space that was in the grid container. So if you add a longer word or something with a width defined to one of those tracks, then the auto minimum is larger. And so you end up with something like this. They're still all 1FR tracks, but we've got less space. And so it's only the available space that's being shared out. Which leads us to a very useful bit of knowledge. If you do want 3 equal width tracks using FR units, then you need to make the minimum sizing function 0 by using min-max 0 1FR, which will give you your equal tracks. Of course, will cause overflows if you've got a giant word in there. But generally, you're not going to do that. You're going to be spanning things across tracks if they're larger, so you sort of end up with something like this. So if you've got your sort of 1FR tracks, if you're creating, for instance, a grid system with 12 column tracks, you want to make sure they actually all stay the same size. Use min, max, 0, 1FR, and then obviously control how far things span. You're going to be taking back a bit of control over overflows at that point. And then finally, as you play around with sizing, this kind of everyone's favourite trick, this idea of adding as many columns as will fit into the grid container by using repeat notation and the autofill and autofit keywords. And what's happening in that incantation may make a little bit more sense once you've looked at sizing. Because we're saying to grid, autofill as many column tracks as will fit into the container. And we're handing out a minimum size of 200 pixels. I don't want those tracks smaller than 200 pixels, and maximum of 1FR. So grid adds as many 200 pixel tracks as we can. We get a little bit left over at the end, and that's then shared out amongst all of the tracks. And so we get these nice arrangements of boxes, which will be responsive and flexible without us needing to add any media queries. I was going to notice we get these gaps in the arrangement where we've got an item which is too big to fill in a gap. It'll just drop down to the next row. Unless we set autoflow to dense, and then we can get the filled in gaps with autoflow dense, able to create a grid with flexible number of flexible columns, pack it densely, and the browser just does this stuff for us with a few lines of CSS, which is pretty magic. Now, there's so many creative possibilities here around sizing and around playing with these sizing functions and allowing your content to kind of dictate to some extent how the layout works. And there's lots of interesting stuff here that really we haven't started exploring yet because we've only just been given the ability to do this. And then there's something else that's really important about grid layout. It really doesn't matter which way up your grid is. So when I first started talking about grid layout, like long before grid shipped in browsers, I would go through all of the properties for grid and explain them with little demos. And I'd explain that you could define all 4 lines of a grid area with the grid area property, and that the order of those lines is grid row start, grid column start, grid row end, grid column end. And if you think about it, that is actually the opposite way round to the way that we specify margins and paddings as a shorthand. And everyone's like, what? And why? And are the CSS working group trying to make our lives really hard? And it turns out the reason for this is that our values in CSS, our properties and values in CSS, are moving away from the underlying assumption that all content on the web is written in English, or at least written in a top to bottom, left to right manner. So we're changing the way layout works to remember that actually English is only one language on the web. There's lots of other languages, and they don't all get written in the same way. And so newer CSS kind of cares about things like writing modes and the writing mode of the document. And because grid cares about writing modes, it means that if we change the writing mode of our document to a vertical one, everything just still works in the same way. So this is a writing system with a horizontal writing mode. Now this is English going left to right, but the horizontal writing mode is exactly the same if you're using Arabic going right to left. Now in any horizontal writing mode, the block dimension runs down the page. So the blocks go down the page, that's the block dimension running down the page. So when you see mention of the block axis, if you're working with grid or flexbox, that's what it means, the direction in which blocks go down your page. And so then the inline axis is the one that goes along the lines, because that's sort of inline. You know, if you've got some text that's running in line, it runs along line the sentence, but that's the inline axis, the way your sentences flow. So that means if you've got a document with a vertical writing mode, then the inline direction is actually top to bottom, because that's the way the sentences flow. And the block dimension runs horizontally. So if we look at that in grid, so this is in grid layout, in a horizontal writing mode, the inline axis is running horizontally and the block axis vertically. Flex layout is a bit more complex because obviously we can specify a flex direction of row or column, which means that we're changing which is the sort of axis that we're working on. So in flexbox, we tend to talk about the main axis, which is where your flex direction is running, and the cross axis. Because that's a bit easier to think about than wondering whether you're block or inline, because you can actually change that in flexbox. But if we go back to grid, if we're setting the start and end lines of a grid area, all we know is that we have start and end lines. We don't know if we're top, right, bottom, or left, because we're trying not to care about that anymore. So here's my 3-column, 2-row grid, and if I want a grid area in a horizontal left to right writing mode to cover the first 2 column and first 2 row tracks, so we get something like this. We can see how the column and row start and end lines kind of line up and the grid area property. So what we're doing is we're setting both starts, then both ends is what we're actually doing, rather than kind of rotating around the clock. And if we were in a language such as Arabic, which is right to left, it's exactly the same. We'd use the same grid area values, but start is now on the right. And so that block is the start line, is the right-hand line, so the block is on the other side. And if we end up working with a writing mode that has our content running vertically, we have this. So grid works in exactly the same way, whichever way up it is. Line-based positioning works exactly the same way. It doesn't matter which writing mode you're in. And if you want to play around with this, I would suggest doing it using the Firefox Grid Inspector, because it will highlight the row lines and column lines, and you can sort of see which way round your grid is working. So these are screenshots from Firefox of the example I was just demonstrating, which you can see online. Firefox DevTools adds line numbers and so on in a grid outline, so you can see how the positioning works. Yeah, if you're working with grid, absolutely, have a copy of Firefox. If you get Firefox Nightly, because you get all the cool new stuff, they're actively working on these kind of designer tools in Firefox. That means that you can sort of inspect your grid and see exactly how things are working. It's just brilliant. It's really, really useful. I find it very helpful, especially once you start to do very complex grid layouts and are just wondering why things are ending up where they are. And the thing about understanding the writing modes hopefully starts to help with another area of confusion. How does alignment work in grid layout? Because alignment also considers the writing mode of your document. And so we don't think about left and right, top and bottom. We again think about start and end in each dimension. And when we're in grid, we've kind of got these 2 different things we might want to align. We want to align the tracks themselves. If you've got extra space in your grid container, where do you want the tracks to end up? Do you want them to space out or not? And then we have the actual items. So whatever you've put into a grid area, how do you want that to behave? Do you want it to stretch out, or do you want it all to sit at the top or go into the centre? And all of this happens in the box alignment specification. That huge grid spec, that's just the half of it. Of course, grid interacts with other specs, and box alignment was essentially all of that cool alignment stuff that started life in Flexbox, taken out and put into a new spec so it can be shared by other layout methods. So the alignment in grid and Flexbox is pretty much the same. So let's look at aligning our tracks. Now I've got a grid container which has got some fixed size tracks in, and the total amount of space needed to lay out those tracks is less than the width and height of the grid container. So I've got some empty space there. I've got some free space to play with. And so that by default they line up at start. So they're lining up at the start. We're in English. They're lining up basically top and left. And so if we want to align those tracks, we're going to use the content properties, align content and justify content. And they deal with free space. What are we going to do with our leftover space? And align content works in the block dimension. So we know the block dimension is going down the page if we're working in English, and then justify content works on the inline dimension. So if I want all of my tracks to go to the end of the grid in the inline direction, so that's going along the sort of rows, I say justify content end. And all the tracks go along to the end because the free space has been put at the start. If I'd like them in the centre in the block dimension, I can say align content centre. So now the free space in the block dimension is put before and after, which then centres the tracks. So what we're doing here is distributing space. We decide where we want our tracks to be, and then we sort of deal with the space left over. So it's pretty much just like Flexbox. When you use those properties in Flexbox, you're distributing the space between the items. And you can use the keywords space between, space around, space evenly, just like in Flexbox. You can use that in Grid too. And if you've used those in Flexbox, this is going to look very similar, but there's a little bit of a difference with grid, because obviously in grid we can have items that span over several tracks. And so when you space things out, you might have specified a gap, which could be, say, 20 pixels, but that gap is now going to get bigger because you've said, well, share out the free space. And that means that it's also going to make any item that crosses the gap bigger too. So here's our items start, and we've got one bigger item that's spanning over 2 columns and 2 rows. But if we do space around in the block dimension and space between in the inline direction, now that's grown, that item has got bigger. So that's kind of, you need to think about that in terms of your design. If you're going to have things that suddenly get larger, well, how does that actually work in terms of the design? But otherwise, this works pretty much like working in Flexbox. And this all works in exactly the same way if you use a different writing mode. So start in the inline direction is always where your sentence starts. Start in the block dimension will be start of where the blocks are going down the page. So like this, if we're working in the vertical writing mode. In the code, you'll see there's a use of block size instead of height and inline size instead of width. These are new logical properties for CSS. I don't have time to go into that. I could do an entire talk just about these logical properties. But I've published an article on Smashing Magazine which has gone into these in excruciating detail if you really want to know how they work. But they are something that's coming to CSS. Is this sort of replacement of things like width and height and top and bottom with logical properties and values that will let us create designs which actually work properly in different writing modes. So that's a link to that article. I'll say all this stuff will be online later. So you can go through and see with some little demos how those logical properties and values work. So then we have the items sort of inside the grid areas. We've positioned an item, and then how is that going to align inside its area? So there we have align items and align self, justify items and justify self. So when we align items or justify items, what we're doing is we're setting all of the self properties on each of the items on the grid. So the default for these things is stretch unless the item has an intrinsic aspect ratio. For example, an image. If you put an image, if the image is actually a grid item, it would be aligned to start. This is so we don't stretch your images all over the place, because you tend not to want that. If you want to stretch it, you'll do that yourself. But other things will stretch, which is why you kind of get your full height columns by default if you use grid, because the default is stretch. So then we can change that. So we can justify items end on the inline axis. And here we can align items start on the block axis. Again, block is the align and justify for inline. And if you use the Firefox Grid Inspector, you can see the areas are still the same size. What we've done is we've just aligned the content inside that area. So what align items and justify items is doing is setting those self properties. So if we wanted that image, for example, to stretch rather than align to start, then we're targeting that and we're saying align self stretch, justify self stretch. And that means that that image now is being treated differently to the other items. So you've got all this new ability with sizing. You've got these new alignment features. You've got the fact that grid layout respects writing mode. We've got all sorts of really cool stuff in grid that is just very, very difficult to do or impossible to do in other layout methods. But I wanted to finish with the kind of third thing that I am repeatedly saying this year. When I show people this stuff, typically someone will ask me, is there a polyfill for this? A polyfill that will fix all of this in older browsers. Can I have that? And the answer is no. No, you can't. And this is why. We've got grid support in all of those browsers. But what Can I Use is pretty bad at showing is the unupgradables. The people who are stuck on browsers because their device doesn't support an upgrade. Now, we have people who are maybe stuck on an old version of IE because their company refused to upgrade. But increasingly, the browsers that can't be upgraded are mobile browsers, often outside of Western countries, running on slower, older hardware and expensive data plans. Why would you force a bunch of JavaScript onto a low-powered device? So the things grid is doing, they perform incredibly well. I did a whole bunch of tests recently to find out if any of these sort of layout methods in grid were expensive. And it turns out, no, they're not. You can pretty much use all of the different capabilities of grid. You're not going to see a significant performance hit. What does not perform well is JavaScript trying to mimic grid. It is horrible. Just try and do, equal height boxes on a float layout with a decent amount of content using JavaScript. It's nasty. Look at things like masonry. Not good for performance. And that's the sort of stuff you're going to start trying to do if you try and polyfill grid, and you're going to do it to those old browsers. And the thing is that new CSS can actually help you create a better experience for the old browsers, even though they don't get the shiny new layout, because it's so lightweight. The grid layout that lets you do a 12-column flexible layout with all boxes in a row as tall as each other is 4 lines of code, plus a line of code for each uniquely positioned item. You can afford for those few lines of code to be downloaded by a browser that doesn't support it, on top of whatever it does support. And we don't need to leave older browsers with no layout, because you can create fallbacks using CSS for those older browsers, because new CSS knows about old CSS. And so that lets you kind of build a simpler yet usable layout for your old browsers and your non-supporting browsers, and then kind of overwrite that with all the shiny new cool stuff for grid. So just as you build a layout tailored to small screen devices by using media queries, you can build a layout tailored to non-grid supporting browsers using feature queries. And it turns out it's pretty much the same thing. We're providing a good experience to users, no matter whether they're accessing the content on a low-powered phone, or an iPhone X, a small laptop, or top-of-the-line Mac or Windows machine. It's all the same. We're looking at, well, what capabilities does this device and browser have, and let's serve them something that makes sense in their context. So I think seeing media queries and feature queries as pretty much the same thing is really useful, because we're just saying, well, how do we shape this content for the different people who need to see it? What features does this device have, and what features does this browser have? So if we consider what happens if our user has almost nothing, we just structure our content well. That's got to be the start. So content is going to load in block layout. That's what content does, unless you start doing something with it, which will be pretty good for limited small screen devices. If you've got a tiny little phone, then just lining the content up in a sensible order is probably the best thing you can do for that. It's much better than a janky experience of trying to load in a load of JavaScript to do something neat. Just show them the content. Let them read the content and use it. But perhaps it's a small device that does have CSS grid. So it's an iPhone, a new iPhone, it's all updated, it's got grid. And so I'm going to enhance that layout with a little header detail with one of my sort of favorite tricks with grid. So what I'm doing here is I'm using generated content just to add a little line either side of the header. So you end up with something like this, which was an absolute pain to do in non-grid browsers. Really easy to do with CSS grid. Now, if you're just doing a little line, it'll probably actually just fall back and you won't see it in a non-grid supporting browser, because we're using a border top on a content that has no width. But if, for example, you wanted to pop a little icon either side of your header with generated content, well, that would appear in a weird place in a non-grid browser. So perhaps we don't want that to show up if we haven't got grid. So here what I'm doing is I'm going to use feature queries, so I'm using @supports, to check to see if the browser does support grid layout. So here I'm saying, hey browser, do you support CSS grid layout? The browser says, well, yes, I do. I said, great, here, have this CSS. And the browser will then load that CSS. Now, a browser that doesn't support feature queries is just going to throw the whole block away, because this is what browsers do. They encounter some CSS they don't understand. They look at it, they're like, don't know what that is, and they just dump it. They don't run it, so nothing bad happens. And the nice thing about using the feature queries is we can wrap all that stuff up so that no parts that would be interpreted by old and new browsers kind of get run by the older ones. And by having this stuff kind of after the CSS for the older browsers, what happens is we can overwrite the older stuff, just like you would with media queries. If you wanted to build something for your narrow layout and then you wanted to overwrite that in the media queries, you just make sure that that happened in the right order. So here we've got mobile with no grid and mobile with grid. And by the way, that circular image there isn't anything fancy. It's a square image. I just used border radius on it to make it round. It's worth remembering that old CSS still exists when you're using new CSS. I have a recurrent request from people asking how they can recreate floats in CSS grid layout. I'm like, maybe just use a float. It's still there. You can still use it for the things they're good for. So I think it's quite easy to think once you start using something like grid, it's like, oh, this will do everything for me. Well, no, the idea is it's kind of part of the picture. And things like floats and so on will go back to being what they were for, rather than us trying to use them for layout. So back to our design that we're building up. As we get a bit wider, I'd like to do something nice with that image. I'd like to float it left and cause the text to curve around it using shape outside. So here I'm using shape outside margin box, which gives us this. Now, if we're using CSS shapes, we just use that shape outside property and a browser doesn't understand shape outside, it will just ignore it. Just say, browsers come across CSS they don't understand and they just pretend it doesn't exist. So we'd end up with this. And there's a bit of a kind of fallback in CSS shapes because to use CSS shapes, you have to float the thing. So you've already got a floated item, and then you're really just saying, well, does the text curve around or not? Now, this screenshot is actually in Firefox, and Firefox don't currently support CSS shapes unless you use nightly and maybe enable a flag, because they're bringing out support later this year. Firefox will ship their shape support. The nice thing about using something like this is that when Firefox do launch their shape support, the site will just enhance, and people who are viewing it in Firefox will be like, oh, that looks a bit neat, they've done something there, and of course you haven't done anything. The browsers are sort of improved, and so the site's kind of improved for the users. So then we start to get a bit wider, and now the text underneath is kind of getting it's getting a bit long, isn't it? We'd like to break that up into 2 columns. Now, another layout method that exists that does something that nothing else really does is multi-column layout. I'm the co-editor of the spec, so I kind of have to put some multi-col in every presentation at this point. So I'm going to use multi-col because the other nice thing about it is it's actually really well supported. Multi-col goes a long, long way back. So we'll do column width 15M, and we'll only get 2 columns when the available space is wide enough to support them. Now, the problem with multi-col in a web context is if someone's on a very short screen, say a phone in landscape mode, or something that's got a little screen, then you're going to end up scrolling up and down to read the content. Now, this is not a good reading experience. We don't want to do that. So we could use a vertical media query here and check for height. That way, we only get our columns if we've got enough height. So the vertical media queries can be really useful. I think we're used to thinking about screen width, but particularly with new layout methods coming in where we can control things in 2 dimensions, we can start thinking a bit more about the height available as well, and do a layout from all dimensions. So that said, we're getting there. The columns only kick in if we've got enough room for those 2 15M columns, so we don't need to add any width media query. We'll just not get them if it's too narrow. And we're not showing them on very short screens. So to finish off this article component, what I want to do is to do something with the cards at the bottom of the layout. Now we've got some room for them to display more than 1 in a row. I'd like to arrange them into a grid. I'd like them to line up with those columns if there's 2 going across. And so we can start to do that. So I'm setting resources, which is those boxes, to max width 60M. And I'm using that grid autofill functionality to fill the container with columns which are a minimum of 15M, which means we only get more than 1 column if we get bigger than 15M. If we get enough room for 2, we'll get 2, and we'll max out with 3. If we get 2, they will line up underneath the multi-col element because the 1M is the default column gap for multi-col. So we're able to start enhancing this layout by writing very little CSS, and sort of getting away from having to use too many media queries because of the sort of intrinsic responsiveness of our new layout methods. Now, this is only going to work for people who've got grid, so we need to decide how we're going to deal with this for our non-grid browsers. Now, you could just leave it alone. You could say, I don't have many non-grid browsers, this is fine in block layout, I'm just going to leave it, and that is reasonable enough. But otherwise, we could try out some other layout method. So let's try inline block. So here I'm saying, I'm going to use display inline block, give things a width, and then what I need to do inside my feature query, I can ignore the inline block because the minute something that's inline block becomes a grid item, the inline blockiness just goes away. But we need to set that width back to auto so that we don't end up with something, a small part of the grid track that it's in. So that's inline block, which does mean that our cards will run left to right. It's not quite as neat as the grid version, but it kind of works. The other thing we could do is use multicol as a fallback. So here's a multicol example, very simple. We are, using multicol. The only difference with this, of course, is that multicol goes down and then back up again and down the next column, which may or may not work for your content. But multicol actually can be quite a useful fallback for grid layout because the minute the things with column, counter column width become a grid container, all that columnness is kind of thrown away and we don't do it anymore. And so I'm showing you a few tips for doing fallbacks, but the point of this really isn't to show you how to do fallbacks for grid. It's to show you how little code you need to do fallbacks for grid. And if you work component by component through your site, you find you don't actually have to do very much to create a decent layout for those browsers that don't support the newer layout methods. We really can achieve a lot with a very little CSS. And I think that is very exciting, and the fact that those things are coming into CSS, things like feature queries, things like the fact that grid knows about old CSS and just overwrites it, can let you do very elegant fallbacks without writing very much code and without needing to ask people on the most limited devices to download a whole bunch of JavaScript to get the layout you dreamed of when all they want to do is read the content or use your application. So I think this drive to make new techniques look the same in our browsers, what you can do is end up creating a suboptimal experience for the very users we claim to be trying to help. Before worrying if the techniques you're using perform well, ask if you actually need to use it at all. And to do that, you need to reframe the discussions you're having around browser and device support with your clients and colleagues. It shouldn't be how do we make this look the same in all browsers. It should be how do we give a good experience in all browsers. Don't worry about making the experience the same because they don't know. They're not checking your site in all the browsers and devices. They just want to be able to use it. Make their experience good. Because increasingly, we've got these tools that let us create great experiences for everyone. We're in a better position now than we ever have been to do that. Don't let lack of support hold you back from using all this new stuff because you can use it. You can do some really great creative stuff that was impossible a few years ago. But likewise, don't let all the shiny make you forget about those who don't have it yet. It's become a bit of a sort of trite thing for people to say from conference stages that the web is for everyone, but I completely believe that. I've never been here to build shiny toys for rich people. And even with the ways that the web has been used recently for some not very great things, I still believe that we've got a huge amount of power to share content and to open up parts of the world to people and to educate and to see exactly how other people live and work and the things that are important to them. That is incredibly powerful. And I want the web to remain accessible to everyone so that everyone can have a part of this. I think it's very important. So thank you very much. All of my stuff is at that URL. I've been sending out tweets, hopefully, while I've been talking, so you'll be able to find some of this stuff. And yeah, come and talk to me later. I really like talking about CSS, as you can tell. I'll be very happy to answer any questions if you grab me in the hallway. Thank you.